Hello, so today we are looking at question 112 path sum. So let us first go over to this and whoops, what did I do? Okay, nothing. And draw this diagram over here. Okay. Wait, that was what? 5, 4, 11, 12. 5, 4, 11. I think it's like that. 12. And then the rest of the notes doesn't really matter, I think, because they want the sum to be 22. 32, I think. 22. 5, 4, 11. Oh. Okay, I drew it wrong. You know what? I feel so dumb right now. I could have just drawn it like that. Yeah. And then swapped over the screens, right? Genius. 2, 8, 13. 4, 1. Okay. Now we can clearly see this. And then they want the sum 22. Okay. So intuitively, how would we do this is we would just go through 5 plus 4 plus 11 plus 7. Is that 22? No. 5, 4, 11, 2. That's 22. We have one answer here. Okay. And then we check path by path to see if it adds up to 22, right? Okay, so that's how it is. Yeah. So how we can do this is, again, recursively check each node and make sure that by the time they are the last node, the leaf node, we want to make sure that the sum accumulated from root to the leaf node is equals 22. So how we can do that is by deducting this each node at each level from this total sum. And by the time we reach the last node, we want to check and make sure that the remaining sum is equals to 0. So for example, 22 minus 5, that's 17, and then minus 4, that's, I can't count, 13, and then minus 11, that's 2. Just nice, at the end of this node it is 0. Okay, great. So how we can write this algorithm is, our terminating condition happens when the last node, at the last node. So if, change the color, if at last node, leaf node, if remaining sum equals equals 0, we return true. So we found one path. Basically the question is asking for, does the path where root to leaf path where the sum of the values on the nodes equals to target sum, right? So apparently there is a path over in this case. so we return true. This is the terminating condition. So how do we write the recursion, right? So what we want to return is, at this step, check at this step. So when we want to think about recursion, we can think of empty boxes. So at this step, let's change the color. Oops, I don't like red, so green. At this step, we don't know if it's true or false yet. We don't know. So we want a condition or a statement that gives us this ability to traverse down this path of nodes to determine if it's true or false, right? So true or false, we don't know. And then basically how we can know is by looking at the left or the right. So at this node, we look at the left. Right node does not exist. Oh, actually, you know what? Let me draw it here. At this node, we look at the left or right. Okay. Right does not exist. Left node. Okay. Left node does not terminate, so let's look either left or right. Again, left node exists. Both left and right node exist. We look at left or right. Left or right. So we keep passing the left node and the right node down, and then we still, at this point in time, 11 and 8, we still don't know, right? But then at 7, we will already know this. At this 7, we can tell that it is not 0. Okay, so false. We return up false on this recursion on this side. But remember, this is all we return. On the right side though, it is 0. So we return true on this side. And then over here on the left side, or another one, left, right, this one is also false, right? Not 0. And then this one is not 0. So this returns false, back up the recursion. This is true, false, returns true, and then again true, false. This is, oh, we have to remember to add in a null check. Okay, so blah blah, return false, and then now true or false, it returns true. So how do we write the statement for this recursion? We can do something like return can't write. Return either this function, let's just call this, I don't know, find some function. Okay, so return this find some function, pass in the left, or find some function, pass in the right. Okay, so I guess that is it, because at this, it keeps on returning down the down this recursion path to keep returning either true or false, right? Okay, so let us now go back to our question. Nope, this one. Okay, first let us define the function. No, return self dot has some, call it, pass in root, pass in target sum. Okay, now let's define the function has some root target sum. Okay, so terminating condition, remember we want to start off with that, is basically if at the leaf node, the last node, check if remaining sum is 0. Okay, so if root dot left is none, yeah, okay, if and root dot right is none. Wait, should it be or and? Hey, let me think. Okay, it should be and, I think. We return, yeah, return check if the value target sum remaining, I'm gonna rename this to remaining sum, remaining, cause I'm gonna keep operating on this remaining sum. Return remaining sum equals 0. This basically checks if remaining sum is 0, right? So now we want to pass in check return has self dot has sum, check if the left side, I feel like I spelled remaining wrong. Yeah, remaining sum minus root dot value, or self dot has sum root dot right remaining sum minus root dot value. Should I just write it here instead? Remaining sum minus equals root dot value. Then this will be remaining sum. Ugh. Okay, none type. If root is none, return false. Okay, calm down, let's figure out how to fix this. If has some remaining sum, huh. Let me debug this by printing out stuff, right? Feel like it's close. Don't really know why this is happening. Let's print it out and see what runs. 17. What's the target? Oh, okay, so we go 17, we go -4. Let's bring up the 13, right? 13 to, okay, it goes 17 13 minus 11, that's 2. It does not check this branch. Why is it 9? Let me pause the video and debug. Oh, okay. It is because print remaining sum. Let's print another remaining sum here and see what happens. Here. Run code. 2, 2, it does not go to 0, even though it should. So at this point in time, we want to make sure, oh, okay, so we want to minus root dot value. Let's run it again. Perfect, looks like it's working now. Let's remove the print statements and submit it. I did this yesterday and I already forgot. Okay, perfect. Thank you for watching this video.